alpha A is not equal to alpha S. Okay, let alpha A is greater than alpha S. So thermal expansion of aluminium, see, ends are welded to one another, so they cannot expand freely. Expansion of one is dependent on the expansion of the other. Compression of one is also dependent on the compression of the other, because ends are welded together. Let us assume that alpha A is greater than alpha S. So since coefficient of linear expansion of aluminium is greater, this middle rod, it will have greater thermal expansion compared to the thermal expansion of the steel rod. This point is vital. Middle one will have greater thermal expansion compared to the thermal expansion of the outer ones. Okay, that means the thermal expansion of aluminium is greater than thermal expansion of steel. Okay, so aluminium rod, suppose it expands by 10 centimeter, while steel rod elongates by 8 centimeter. Thermal expansion of aluminium is greater than thermal expansion of steel rod. Assume that the thermal expansion of aluminium is 10 centimeter, thermal expansion of steel is 8 centimeter. Okay, but since they are welded, the steel rods will be pulled to 10 centimeter. 8 centimeter normal thermal expansion, but steel rod cannot stop there because the ends are connected. So the steel rod will expand from 8 centimeter to 10 centimeter, but that will not be thermal expansion. That expansion will be by pulling. Who will pull? Aluminium rod will pull. Okay, so steel rod will have what? Normal thermal expansion plus mechanical expansion. Okay, normal thermal elongation, that will be followed by some extra elongation which is mechanical in character. Okay, so will the steel rods be under tension or under compression? Tension. So it is confirmed that each steel rods will be under tension. Let this be TS. In this also TS. Now consider aluminium. What is happening to aluminium? Aluminium rod has expanded to 10 centimeter. Okay, then during that process, up to 8 centimeter there is no problem. Up to 8 centimeter, aluminium has expanded to 8 centimeter, steel has also expanded to 8 centimeter, there is no clash. But from 8 centimeter to 10 centimeter, the aluminium rod is pulling the steel rods, or in other words, steel rods are trying to compress the aluminium rod. Okay, so two steel rods, they are trying to compress the aluminium rod. Aluminium rod is trying to elongate. So aluminium rod, will that be under tension or under compression? Compression. Aluminium rod will be under compression. So all of you know about the direction of compression? This is the sense of compression. So the better one, a bigger one, these two, tension, and this will be, I will mark this as TS, and this tension TS, compression, this is the direction of compression, compression, it is TA. Is it okay? Have you understood the process? Simple explanation. You take this example that aluminum expansion of aluminum is greater because its coefficient of linear expansion is greater. Suppose expansion of aluminum rod is 10 centimeter, but normal expansion, thermal expansion of steel rod is only 8 centimeter. It is smaller because its coefficient of linear expansion is smaller. But at 8 centimeter, the steel rod cannot stop because the ends are welded. So from 8 centimeter to 10 centimeter, steel rods will be pulled. So that means two steel rods, they will be under tension, while the aluminum rod, it will be under compression because the two steel rods, they are trying to compress that. They are not allowing, they are opposing aluminum rod and they are trying to compress the aluminum rod. Okay. Now as we have done in the previous problem, if you consider the equilibrium of this end, consider the equilibrium of a layer at the end. This layer is not moving, so total force in this direction is equal to total force in opposite direction. Okay, so we will get our first equation that 2Ts equal to Ta. Okay, so I am drawing the ends separately here. TS TA for equilibrium of the end of the system 2Ts equal to TA. Have you understood this first equation? Now your second equation. There are two unknowns, Ts and Ta. Okay. Second equation. What will be your second equation? Keeping in mind the fact that final lengths are all same. Final length of steel rod equal to final length of aluminium rod. Okay. The steel rod has undergone what? Steel rod normal expansion, its own, then followed by thermal expansion followed by mechanical pulling, mechanical expansion. Okay, so for steel rod final length equal to thermal expansion plus mechanical expansion. For each of steel rods, final length equal to thermal expansion plus mechanical expansion. Before that, initial length. What is the initial length? L0. Is it okay? L0 plus thermal expansion plus mechanical expansion. And we can write this L0 thermal expansion, L0 into alpha S, rising temperature is theta. Mechanical expansion, do you remember? In the last problem only, we use this y equal to F by A by del L by L or del L. This one is actually mechanical. Mechanical equal to FL by AY. Okay. So F, how much force is acting through the steel rod? TS. So TS into L0 by A into YS. Is it okay? Now, for the aluminium rod, For the aluminium rod, final length L naught. Now I am considering the aluminium rod which is sandwiched between two steel rods. So aluminium rod is undergoing is normal thermal expansion. Okay. Then on both the sides there are two steel rods which are trying to compress it. So its initial length L naught plus thermal expansion minus mechanical compression. Minus mechanical compression. L naught plus thermal expansion followed by mechanical thermal expansion minus mechanical compression. Is it clear to all of you? Okay, steel rods, they are reluctant to elongate, but aluminium rod is trying to elongate them. So steel rods are reacting, they are trying to compress the aluminium rod. Equal to L naught plus thermal expansion. L naught alpha into theta minus mechanical compression. What is the force acting through the aluminium rod? TA into L naught divided by A into YA. Okay. So can you form your second equation? Because final lengths are all equal. So final length of steel rod is equal to final length of aluminium rod. We'll get our second equation. Since final length of steel rod equal to final length of aluminium rod, hence L naught plus L naught alpha s into theta plus Ts into L naught by A into Ys L naught plus L naught into alpha into theta minus TA into L naught by A into YA. Is it okay? So L naught cancel, and what you have to find? You have to find the final length of each. So you can see here that TS and TA, two different things, but you have a relation between TS and TA. So in place of TA, you write 2TS, and then from this equation get TS. Okay, once you get TS, you will put the value of TS in equation 2 to get the final length. Okay, this is equal to TA equal to 2TS or TS into L naught by A, TS into L naught by A into 1 by Ys plus 2 by YA equal to L naught theta alpha A minus alpha S, or TS equal to Ts equal to Ts is not Ts by A. Ts L naught by A, whole thing is equal. So you may use this. Ts L naught by A equal to L naught will cancel now. Okay. Or Ts equal to A theta alpha A minus alpha S into Ys Ya divided by Ya plus 2Ys. Okay, so this is Ts. Now we'll use 2 to get the final length. From 2 from equation 2, final length equal to L naught plus L naught as alpha S into theta plus Ts A theta alpha A minus alpha S Ys Ya by Ya plus 2Ys into L naught by A Ys. So Ys will cancel, A will cancel, and we'll get our answer in this form: 1 plus alpha S into theta plus alpha A minus alpha S Ya theta divided by Ya plus 2Ys divided by Ya plus 2Ys Ya alpha is theta 2Ys alpha is theta plus alpha Ya theta minus alpha S Ya theta. So alpha S Ya theta, this will cancel, equal to L naught into 1 plus theta into alpha Ya plus 2 alpha S Ys divided by Ya